So this is actually probably going to be a fairly interesting video. Here on my test bench today I have two things. I have a GTX 580 from EVGA, and I also have an 8600 GTS, so that's a bit of a mismatch, you'd think. What I will be looking at today is the performance impact of a high-performance graphics card versus a low-performance graphics card as a dedicated PhysX processor. So this GTX 580 is going to be doing all of my graphics processing regardless, and then I'm going to run two different scenarios. I'm going to run with the 8600 GTS as my dedicated PhysX card, and then I'm going to try running with another GTX 580, which is obviously ludicrously overkill, as my dedicated PhysX card. So if you guys check out up here, I have my PhysX configuration set. So I have selected the 8600 GTS as my dedicated PhysX card, and I'm going to try with both scenarios, and I'll let you guys know how it goes. Well, I've already run into some interesting results. So I'm running at 1920 by 1080 on Mafia 2. I'm running with high details, 8xAF, anti-aliasing is on, and I've already run only two scenarios. So I've run the GTX 580 with the 8600 GTS as a dedicated PhysX card, and then I've run the GTX 580 ignoring the 8600 GTS, so using itself for PhysX. You can force that in the driver as well. And it actually scored, the GTX 580 actually scored 66% higher by itself than it did by tying it down with this 8600 GTS to do the PhysX processing. So let's see what else we can investigate here. So at this point, guys, I've run quite a few more fascinating scenarios. So here you can see my GTX 580 running a GTX 550 Ti as a dedicated PhysX card, but I've actually finished all of the run-throughs that I am going to do, and I just want to share with you my results. So this is also going to be a sneak peek into what my next episode is going to be, looking at PCIe bandwidth and the effects on gaming performance. But here I have my full results. So the GTX 580 alone gets about 50 frames per second. You throw in a PhysX card that's too slow, and it goes all the way down to 30 FPS. So what that means to me is that you're far better off to just let this card do both the graphics and the PhysX by itself than to give it something that's so slow that it bottlenecks it and that the PhysX calculations are going to be behind the rate at which this card can draw the frames. Okay, so that is clearly a problem. Okay, so then I tried a few cards of varying power as a dedicated PhysX card. So I tried an additional GTX 580, I tried a GTX 560 Ti, as well as a GTX 550. So I don't know where the threshold is, but it looks like this is how it works for PhysX, because these three are all within margin of error of each other, regardless of how much PhysX power we're throwing at it. I mean, a GTX 580 is clearly overkill for PhysX processing, but you can see that the 550 Ti and the 560 Ti are also both just fine. So the answer is, I don't know exactly where that threshold is, and it's going to depend from game to game how much PhysX processing is needed, but what you need for PhysX is a card that is fast enough, not too slow, because that will bottleneck your entire setup, and not so fast that you're spending way too much money on it. So something like a 550, or even something a little bit lower end, or maybe a last generation card that you can get your hands on the cheap, is probably the best bet if you have something like a GTX 580 as your main card. So thanks for checking out this little PhysX episode of Linus Tech Tips. Don't forget to subscribe for more unboxings, reviews, computer videos, and other good stuff like that.